Hello everyone. So as we are discussing chapter 5 of class 10 periodic classification of elements, and in the last tutorial we have started with the last topic of the chapter, that is the trends in the modern periodic table. Trends means that how the various properties they are going to differ along a period as well as down a group. So, right in front of you, you can see that there is the Bohr model of an atom. So, this is called the Bohr's model of an atom. And if we see the Bohr's model of an atom, we can very well figure it out that in the center of the atom, we have a positively charged nucleus, and around this positively charged nucleus we have various shells, and the shells either they can be labeled with the alphabet starting from K. So K shell is nearest to the nucleus, then L, M, N, and so on like this. Or we can also do the numbering of the shells starting from 1, 2, 3, 4, right? The 1 is the nearest to the nucleus, and then we can move away. Okay, now the trend that today we are going to discuss is the atomic size. So this is the trend that we all will be discussing, atomic size, that is the size of an atom. Okay, and how this size is going to vary along a group and along a period. So this is our study for today. So first of all, we need to understand that what is actually atomic size. So somewhere we have knowledge that the size of an atom, or basically the perfect definition of it is the distance from the center of the nucleus. If this red portion on the screen is denoting the nucleus, then from the center of the nucleus till the outermost shell, okay, since we all can see that the outermost shell is the end shell, so that distance from the center of the nucleus to the outermost shell is called as the atomic size, and it is also called as the atomic radius because it is somewhere giving us the radius of the atom. Okay, so what is atomic size? It is the distance from the center of the nucleus. Okay, from the center of the nucleus we have to start, and the outermost shell of an isolated atom. It means that the atom should be a single atom, it should not be in combination with the other atoms. Okay, and since like indirectly we get the radius of the atom, so sometimes we also refer it to as the radius of the atom. So this is the atomic size, that from the center of the nucleus till the outermost shell where the electron is present. So that size is called as the atomic size. It is also called as the atomic radius. Now second thing is that the smallest atom is of course the hydrogen atom, because there is only one shell, right? How do we get to know that there is only one shell? Hydrogen, the atomic number is 1, and number of proton is also 1. Since it is a neutral atom, so it means that the number of electron is also 1, and if there is only single electron, that will go into the K shell only, right? So this is the nucleus, and if there is only one shell, so this is that electron. Okay, so the atomic size or atomic radius is measured in terms of a unit called picometer. Now picometer means that pico stands for 10 raised to the power minus 12. It means that the size of an atom is very very small. 1 picometer is equal to 10 raised to the power minus 12 meters. So that is the size. Okay, and the size of an isolated atom of hydrogen is just 37 picometers. That is 37 into 10 raised to the power minus 12 meter. So that small is the size of this hydrogen atom. So I think that atomic size, its definition is clear to everybody. Now we are going to discuss that how this atomic size will vary in a group and in a period, right? So let us all start. Now we all can see that we have two atomic models right in front. One is for lithium and the other one is for sodium. Okay, and we all know that lithium and sodium, they all are part of group 1 because we have already discussed in detail the modern periodic table in previous tutorials. If you haven't watched that, you can watch those tutorials also. So now let us all start with lithium and sodium. So they are a part of group 1, and all the elements which are present in group 1, they are hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Okay, and the shortcuts, they are also discussed in one of the tutorials. You can watch the tutorials over there, right? So now we all can see that we have got these two elements, lithium and sodium. So here we are talking about a group, right? So the atomic number of lithium is 3 and the atomic number of sodium is 11. Now we all know that the atomic number means the number of proton, that is 3 over here, and here it is 11. So the nucleus exerts plus 11 positive charge in case of sodium and plus 3 plus 3 charge in case of lithium. Now that is called as the force of attraction by the nucleus. Now since it is the force of attraction by the nucleus, so whenever the force of attraction, it means this force by the nucleus is going to pull the shells inwards. So that force in case of lithium is plus 3 and in case of sodium it is plus 11. So it means that sodium has got more force of attraction. But whenever we will talk about atomic size and we have to find out that which atom is bigger and which atom is smaller, remember that we will always be comparing two forces. First one is the force of attraction by the nucleus, and now we all need to understand that whenever we'll talk about the force of attraction, this force of attraction will always pull the shells inwards. Okay, so it means that the force will pull the shell inwards and the size is going to decrease. And the second factor on which the atomic size depends is the number of shells, right? Number of shells, we all need to understand that if the number of shells will increase, right, the atomic size is going to increase. So there are two factors. One factor will decrease the atomic size and the other factor will increase the atomic size. Now this is the force of attraction, plus 3 in case of lithium and plus 11 in case of sodium. But now let us just compare the number of shells. Now if we compare the number of shells, there are only 2 shells in case of lithium, and if we compare the number of shells in case of sodium, since the atomic number is 11, configuration comes out to be 281. So it means that the number of shells in case of sodium, they are 3. Now the charge is more because the number of this force of attraction from the nucleus is greater in case of sodium. So it means that it is going to pull the shells inward more, and because of it the size should decrease. Okay, and the number of shells are also more in case of sodium. Because of the number of shells, the size should increase. Now there are two factors. One is decreasing the size and the other one is increasing the size. We all need to understand that in this case the number of shells is a strong factor. It is a dominant factor. So the shells, they are more powerful as compared to the nuclear force of attraction. Because of that, the size of sodium is greater than the size of lithium. Okay, so we all need to understand this thing, right? Let us do the next thing over here. So these are 3 atoms, we all can see. The lithium atomic number is 3, sodium is 11 and potassium is 19. Let's find out the force of attraction from the nucleus of lithium. Since atomic number is 3, it will be plus 3. Atomic number is 11, it is plus 11, and atomic number is 19, it is plus 19. So it means that according to the force of attraction from the nucleus, the atomic size should be the smallest in case of potassium, because the force of attraction from the nucleus is maximum, and whenever nucleus force of attraction is maximum, the shells, they will be pulled inwards, and because of it the size should decrease. But there is second factor also on which the atomic size depends, that is the number of shells. In case of lithium, there are only 2 shells. Okay, in case of sodium, there are total 3 shells, and in case of potassium, there are total 4 shells. Now, because of shells, right, so the size should increase. Now again we are in that situation that one factor is causing the decrease in size and the other factor is causing the increase in size. But which factor is a strong factor if we have to compare the nucleus force of attraction and the shells? So you all got it right, that shells are the stronger factor, and because the shells are maximum in case of potassium, the size is also maximum for potassium. So this is the correct order, and as if we can see that this is the distance from the center of the nucleus to the outermost shell. Okay, this is the radius, this is the distance from the center of the nucleus to the outermost shell, and this is the distance from the center of the nucleus to the outermost shell, right? So now we are clear that if we have to decide that nucleus force of attraction and shells in a group, so shells, they are the stronger factor. Now let us take this study to the entire group 1. So now it becomes very easy that in case of lithium, the nucleus force of attraction is plus 3. Potassium, it is plus 11. Sodium, it is plus 11. Potassium, it is plus 19. Then rubidium, it is plus 37. Cesium, it is plus 55. And francium, it is plus 87. So it means that the force of attraction from the nucleus is maximum in case of francium. So because of it, the size should decrease and francium should have the smallest size. But remember that there is another factor also, that is the number of shells. Now let us count the number of shells. In case of lithium, there are only 2 shells. In case of sodium, 3 shells. Then 4 for potassium, 5 for rubidium, 6 in case of cesium, and 7 for francium. Now can we all see that the shells, they are maximum in case of francium, and because of this the size will increase. And which one is the stronger factor over here? Shells. So whose size is the maximum in a group, that is francium. And now I guess that this is clear to everybody that when we will move from top to bottom in a group, that element which is at the bottom, its size will be the maximum or largest because the number of shells are greater, right? And shells, they are the stronger factor. The nuclear force of attraction will also be maximum, but that will be a weaker factor. Shells are the stronger factor. So the atomic size increases down a group, right? So whichever group that is. Now we all can see we have group number 16 over here. So what are the elements of group number 16? Oxygen, then sulfur, selenium, tellurium, and polonium. Okay, and let us quickly understand that what are the atomic number. Oxygen, it is 8. Sulfur, it is 16. Selenium, it is 32. Okay, 34, I'm sorry, it is 34 selenium. Then tellurium is 52 and polonium is 84. So these are the atomic numbers. Okay, then atomic number means that this is the force of attraction from the nucleus also, right? So we have written that this much attraction will be exerted by the nucleus on the outermost shell. Now, as per this, the nuclear force of attraction is maximum in case of polonium. So, size should be minimum in case of polonium, because in this case, the shells, they will be strongly pulled by the nucleus inwards. Okay. And because of it, the size should decrease. But there is another factor. We always have to compare these two factors. Shells, they are 2, then 3, then 4, then 5, and finally 6. So here we have the maximum number of shells, and because of it the size should increase. Now, out of the nuclear force of attraction and the shells, which one is a stronger factor over here? It is the shells, and ultimately the size will increase. So whose size is the largest or maximum in case of group 16 also? It is polonium. So understand this thing, when we move from top to bottom in a group, the atomic size or the atomic radius will increase, because the shells are a stronger factor than the nuclear force of attraction. And remember that shells, they increase the size, and nuclear force of attraction decreases the size. So we are done with the group. Now let us start with the period. So we all need to understand that how the atomic radius or the atomic size now varies in a period, that is if we will move to from left to right. Okay, so I will not be focusing on these two elements because they are part of period 1. Let us start from lithium till neon. So if we can see that lithium, the atomic number is 3. So this is the force of attraction from the nucleus, plus 3. Beryllium, it will be plus 4, plus 5, plus 6, plus 7, plus 8, plus 9, and plus 10 for neon. Basically, atomic number is generally roughly equal to the nuclear force of attraction. Now, this is the nuclear force of attraction. So we all can see that lithium, the nuclear force of attraction is minimum, and for neon it is maximum. Now, as per this, so nuclear force of attraction is maximum in case of neon, so its size should be the minimum as per this. Okay. Now, if we see the configuration 2 1, there are 2 shells, 1 2, there are 2 shells, 1 2, then 1 2, 1 2, 1 2, 1 2, 1 2, and 1 2. So since we are talking about period number 2 over here, so it should be clear to us that in a period the number of shells will be same, and every element in period 2 has only 2 shells, and the 2 shells are K and L. So now let us just figure out that the two factors that we have been talking about, the first factor that affects the size of an atom is the nuclear force of attraction, right? And the nuclear force of attraction, it increases along a period, right? So it was increasing, and because it was increasing, the size should decrease. And if we talk about the second factor, that is the shells, now the shells, they are the same. Now, because the shells are the same, so it means that there will be no role of shells in case of the atomic size in case of a period, because the shells, they are not increasing, they are just the same. Every element of group 2 has the 2 shells, right? Now, in a period, so which turns out to be a stronger factor over here, that is the nuclear force of attraction. In case of group, it was the shells which was the stronger factor, but in case of a period, which is the stronger factor? It is the nuclear force of attraction. Now, which has the strongest nuclear force of attraction? It is neon. But remember that neon is a noble gas, right? It is gaseous, and gases, they have very poor forces of attraction. So what should be the order? That lithium size should be maximum because its nuclear force of attraction is minimum. तो जितना कम न्यूक्लियर फोर्स ऑफ अट्रैक्शन होगा, उतना ही बाहर वाले शेल न्यूक्लियस की तरफ नहीं आएंगे, वो बाहर की तरफ ही रहेंगे. तो लिथियम का साइज बड़ा है, फिर बेरिलियम, it is smaller, then boron, carbon, nitrogen, oxygen, fluorine, but neon will have greater size than that of fluorine because it is a noble gas which has poor forces of attraction. So what do we understand? That when we move along a period, the atomic radius will decrease, okay, till group 17 element, so that is fluorine in this case. And for noble gas, the size will increase, right, as compared to group 17, because the noble gases, they have the poorest forces of attraction. So please go through this. Remember, there are two factors. One is the nuclear force of attraction. If this force of attraction is more, the size will be less. And second factor is the shells. If shells are more, the size will increase. And in a period, nuclear force of attraction is the dominant factor, and in a group, the shells, they are the dominant factor, and they decide the atomic size. Go through it, and tomorrow we'll be comparing the size of the cation with respect to the parent atom, or the size of the anion with respect to the parent atom. Thank you, everybody.